Hello everyone. So we're continuing our conversation on acids and bases, and we're looking now at some examples on the pH scale. So this example says, consider a saturated solution of milk of magnesia, so that's magnesium hydroxide, that has a pH of 10.52. Can answer the following questions for this solution. So what is the hydronium ion concentration of the solution? So this is a normal application of where you need to remind yourself that the pH is equal to the negative logarithm of the hydronium ion concentration. Right? Or, so you can solve it from this. So that means the hydronium ion concentration must be equal to 10 to the power negative the pH. Right? Or that's something that you maybe remember. So we take the pH and we say 10 to the negative 10.52, right? Because we're told that the pH is 10.52. And how the pH works, remember, so we only look here at all the significant figures after the decimal point. And so that means if we round this, we get a value of 3.0 times 10 to the negative 11 molar. Okay. Cool, so that is our hydronium ion concentration. B then says, what is the hydroxide ion concentration? Now I'm going to do this in two manners just to remind you of two different things. So the first thing is that we can remind ourselves that POH plus pH must be equal to 14. That's according to our pH scale. So from that we can then get the POH. Alright, POH is equal to 14.00 minus the pH. pH in this case is 10.52. So that is 3.48. And then you can or should remember that POH has a similar definition to the pH, which is that POH is negative the logarithm of the OH minus concentration. So that means that the POH is equal to the same thing, negative 10 to the power negative 10 negative POH, which in this case is 3.45, and then we get a value of 3.3. Again, two decimal places gives us two significant figures. So 3.3 times 10 to the negative 4 molar. Makes sense? This is a base, so we expect high POH or OH concentration. This is not POH, this is the concentration of OH minus, apologies. That's what we're calculating there. If you solve for the concentration of OH minus. Alright, another way that you could have done it is you could have recalled that the autoionization constant of water is equal to the product of hydronium multiplied by OH minus, right? And that is equal to 1.0 times 10 to the negative 14. Remember, because water forms an equilibrium with hydronium and hydroxide. And it has a K value, a KW value of 1.0 times 10 to the negative 14 at 25 degrees Celsius. So even though it's not specified here, you can always assume that we're working under those standard conditions. So, because we calculated the hydroxide concentration in the first instance, if you kept all your numbers for the hydroxide, you can plug it in here. So, we can then say OH minus is equal to 10. Maybe let me just remind you. So, let's do this in a different color. So this is our alternative. positive. Right, this is 1.0 times 10 to the negative 14 divided by the hydronium ion concentration. Right, and the unrounded value for that, 10 to the negative 14. Hydronium ion concentration is 10 to the negative 10.52, as we got there at the top. So then this will round to exactly the same value, 3.3 times 10 to the negative 4 molar. Okay, so those are two ways that you can relate the hydronium ion, the hydroxide ion, the pH, the pOH. This is just to remind you of how all those things fit together within the pH scale. All right, and I mean, of course, we can see this thing is, so the last question, so let me jump the gun of what the point of this question is. It asks, is the solution acidic or basic? So the solution is highly basic. It's a basic solution. Why? Because the pH is larger than 7. The hydroxide ion concentration is much larger than our hydronium ion concentration. And I mean, we're working here with a base, right? So we have magnesium hydroxide, so that is to be expected. So you can also you can just see that if you remind yourself of how pOH works, we have a very low pOH. So that also indicates we have a basic solution. So all these things considered, that is just to remind you, this question was to remind you of how these things fit together and how the pH scale works. Yeah, and I also wanted to just show you, or remind you, you can also use the auto-ionization of water to link the hydroxide and hydronium ion concentrations. All right, good. Thank you for watching, and I'll see you in the next video.